Here's yet another illustration of how rank dependence can capture how human beings feel about risk. I'm putting up a figure here, page 176 of the book. It's a version of the Allais paradox. The numbers are a bit different than other, but this is one of the versions of Allais paradox. Let us look a bit. First, we look at the right choice situation. Capital K denotes €1,000. The left prospect with certainty, probability 1, gives you 25K. The right prospect doesn't give you such certainty. There's a possibility of ending up with 0. You see it here. But there's another possibility of ending up with a very big, nice amount, 75K. So what would you prefer? Well, most people, and book of findings show, most people really like the certainty of the left prospect so much, they don't like to take any risk, and they prefer the left prospect. So this is the majority preference, what is depicted here. Now we look at the left situation. There's no certainty of what the kind we just saw available. Whatever you do, there's a big probability of getting 0 anyhow. The left prospect gives you a small probability, 0.13, of getting 25K. The right prospect gives you probability a bit more than twice as small of getting a positive amount, but then that amount is 3 times higher. And most people say that amount is so big that we prefer the right prospect. So the preference depicted here is again the majority preference. My first question to you is, can you convince yourself that this combination of preferences violates expected utility? So pause the video, think about it, then come back. Okay, I assume you come back now. So you can see that what we have here is in fact the violation of the sure thing principle. Well, it's for risk, but still the sure thing principle says that under expected utility, common outcomes do not matter. So here the common outcome is the blue 0 should not matter. And if we change it in other common outcome, still it should not matter. So that change should not matter either. Here we replace the common 0 by the common 25K, should not affect preference. In reality it does. So this is a violation of the sure thing principle. And we know that the sure thing principle must be satisfied under expected utility. We can also do a bit more algebraically, just write the formula of expected utility. If you do the expected utility comparison here, you see that the lower branch cancels from the equation, from the comparison. In the right situation, the lower branch, the same way, cancels from the comparison. And if you drop these two, then the same inequalities result. Then the left and right situations are identical. So expected utility says we must have the same preference. Well, we do not find it empirically, so we have a violation of expected utility. Now, maybe, however, rank-dependent utility maybe can accommodate it. Rank-dependent is more general. It allows decision weight to depend on rank. And maybe can we use that again, more higher generality to accommodate the choices found here? That will be my question to you. But maybe first I should say we will see several questions of this kind later in this course. This is the first time you see such a question. I expect this to be a difficult question. But still, let us see if we can make it. And then, so my question to you will be to think about how rank dependence can accommodate these preferences. But the rule of the game is, do not use paper and pencil, only use your mind's eye. Just look at the figure and try to see in your mind how it works. Don't do calculations, but only do qualitative reasonings. Maybe reasoning like, oh, this becomes bigger here, that becomes smaller there. Then I think reasoning of that kind. I'll give you a pause and then you can think for yourself, then I come back, but I will not give you the solution immediately. After the first pause, I'll give you a first hint, then you can think more. Then I give you a second hint, then you can think more. Only then I give the answer. But if already right now, before having seen any hint, you could see a solution, an answer would be quite nice. So you get a chance for that now. So pause the video and think. Okay, so now I continue. I assume you came back. We're gonna use the first hint that I give now is a trick that is often of use when you work with rank-dependent utility. The trick is that try to do it such a way that in every choice situation, all the choice options that you consider there have the same ranking of branches events. And I'll show you in the left situation what I have in mind. And here, when we look at the right prospect, we see the upper branch must have the best rank. because that's the best outcome. Nothing to choose, just that's it. For the left prospect, however, we have liberty. These two money amounts are the same. We can choose how we do the ranking. And maybe I told you a while back that we have that liberty and we often use it. And in this exercise, it will make life much easier to use it, and we'll do it fully. So we're going to say, in the left prospect, we also say the upper branch has the best rank. Now look at the lower branch here. We see from the left prospect, in left prospect, the lower branch must have the worst rank. No choice there. Here we have liberty, we use it, we say, here the lowest branch also has the worst rank. What remains is the middle branch. In both situations, the middle branch has what I call the middle rank. Well, it has rank 0.06, the probability of getting outcome rank better, which is in the highest branch. But then for easy, I'll just call middle. When I say middle rank, I mean 0.06, for easiness of speaking. Next, we go to this figure. We try to get similar things done. First of all, we note the left prospect, all the outcomes are the same, so we have complete liberty of choosing the ranking as we like. Of course, we're going to choose a ranking the same as for the right prospect. The right prospect, we see the upper branch has the best rank, so here we also let that one have the best rank. The lowest branch has the middle rank, 0.06, So also this branch, we're going to give the middle rank. Middle branch has the worst rank. So here, middle branch is also given the worst rank. So that is how we take in our mind the ranking in the two choice situations. Now with that hint, I invite you a second time. Please see if now you can set up a reasoning. Pause the video, later come back. Okay, I assume you came back, and I don't give the answer yet. I give a second hint now, and use a concept in your reasoning that I explain now. Let's first look at the left figure for explaining what I have in mind. If you look at the two upper branches, they give you a reason for going to the right, because the right prospect is giving a better outcome in the upper branch than the left prospect. If we look at the middle branches, they give a reason for going to the left, because here the left prospect has a better outcome than the right prospect. Lower branch doesn't give any reason for anything. It's a neutral argument. No argument for going left or right. Let us see how those arguments look like in here. Again, the upper branch gives an argument for going right. Middle branch gives an argument for going left. Lower branch is a neutral argument, neither left nor right. So think about these arguments. Try to see how rank dependence can be brought in, how that can accommodate the choices. And again, pause the video, think for a while, then come back. Okay, I assume you did the thinking that you want to do. Now let me tell you the answer, the solution that I have in mind, the reasoning to make it understandable. But first of all, we compare the two choice situations, we look at the upper branches. In both choice situations, the upper branches have all the same outcomes, the same outcome probabilities, but also the same ranks. So nothing that we see is changing for the upper branch in the left and the right choice situation. And therefore, the upper branch cannot help us to understand why preference has changed. Next, we look at the lower branches, and we see something changes there. Well, the common outcome changes, and also the rank, because in the left situation, it has the worst rank. In the right situation, it has the middle rank. However, these changes do not help us to understand the preference change, because in both the left and the right choice situation, this lower branch gives a neutral argument, neither for going left or right. And if you then pay a bit more or less attention to a neutral argument, neutral it is. So it doesn't help to understand why preference change. Now then let us look at the middle branch. The middle branch always gives an argument for going left. But for the middle branch, we see there is a difference here. In this situation, it has the middle rank, well, 0.06. In this situation, it has the worst rank. That's a difference. And it's common for empirically it is found that people are often pessimistic. They pay more attention to an event as it gets ranked worst. So they may pay more attention to the middle branches in here in the right choice situation where the rank is the worst than here when the rank is in the middle. So therefore, if a rank-dependent utility allows you to assign a bigger decision weight to the middle branches here than here, and that can explain the preference switch, because the argument for going left here weighs more than here. And nothing else really changes in the two choices. So here there's simply more reason for going left than here. That can explain the change in preference. So that's indeed how rank-dependent utility can do it, maybe algebraically, but I hope that you also see that this fits with psychological reasonings going on in the minds of people, because people do have such attitudes. People do pay more attention to lowest branches. For instance, here they see, oh, here there's a lower outcome 0, and I don't have that here. The lowest outcome here is worse than here. It's salient. They pay much attention to it and gives them much dislike for the right prospect relative to the left prospect. Here, such a thing doesn't happen much. The lowest outcome is the same for both of them. And here, this, of course, 0 is smaller than 25k, but this is a middle outcome. This is not so salient, doesn't get so much attention. So I think what rank-dependent utility does in the algebra captures what goes on psychologically in the minds of people. And that's why we like that explanation. One more thing I want to say about it is that, in fact, here we have what they call the certainty effect. People have a special preference for certainty. But we saw a bit of that in risk aversion and expected utility. But there's more of certainty effect. There are components that expected utility cannot capture. And here we see it. Rank dependence is capturing such a component of certainty effect, having to do with strong pessimism, especially when the lowest outcome is involved. So here we indeed see there's more to the certainty effect than expected utility can capture. That's quite a strong phenomenon in the field. Now, I said we do it without algebra, and that is finished now. I'm going to show you a bit of algebra now. I am writing one formula now, and I'll explain to you what I'm doing here. The algebra that I'm going to do now is I'm going to see what happens if I look at the rank-dependent utility of this left prospect minus the rank-dependent utility of, so the rank-dependent utility difference between the choice options. Then the middle branch is contributing to the difference. Well, in both situations, it has middle rank 0.06. So the decision situation is always this number. And then here I write the utility differences. That means that this, what I wrote here, is how much the middle branches contribute to the rank-dependent utility difference between the two prospects. In this situation, same story, I write here how much the middle branch contributes to the rank-dependent utility difference between the two prospects. But you see something has changed. Here, it had this outcome probability of 0.07 has the worst rank. Here it had the middle rank. Here it has the worst rank. In rank-dependent utility, the worst rank or pessimism can receive more weight, can bring more weight than the middle rank. So that's going on here. That's why we can have this inequality. For the upper and the lower branch, they, for the rank-dependent utility difference between the two prospects, they do the same thing in both choice situations. The lower branch, for instance, always give contribution 0. But this is the only difference. So indeed, the difference is bigger in the right situation than in the left situation. So it can well be that in the left situation it's negative, but here become positive, accommodating the preferences. So that's a more algebraic way to explain the preferences that we found. And anyway, this was another illustration of how rank dependence can capture how human beings feel about risk attitude. More to come.